The universe is an endless fractal made out of an endless number of inestimable blasts known as minimal large bangs. On the off chance that you consult a science reading material published before 2006, you will see that Pluto was included as one of the 9 planets in our solar system. However, this is now not the case. Just about quite a while back, the International Astronomical Union, IAU, reclassified Pluto's status and excluded it as a planet. Now, the IAU is again discussing this issue since NASA has provided clear pictures of Pluto, now considered a dwarf planet. Join us on a journey to the far reaches of our planetary system to explore the first images of Pluto in our history. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel, be sure to like this video, share it to reach more people, and turn on the notification bell. We've come a long way since the historic Apollo 11 mission, yet the vastness of space presents many unanswered questions. This is where NASA's heavy James Webb Space Telescope project seeks to discover a universe of its own. This grand project builds on NASA's past missions, and there is great interest in deciphering extraordinary discoveries from ancient times. We are understandably curious to learn more about the Big Bang and how our solar system came to harbor life on one of its planets. The James Webb Telescope, however, has its sights set on the future of our planetary system, revolutionizing our understanding. Although it is important to ask whether we really need to look back for definitive answers about our universe and perhaps reconsider them, the Pluto question has been the subject of debate in the field of space exploration. Thanks to the James Webb Telescope and the discoveries it has provided, we have more and more data to explore our solar system. It seems that the $101 billion investment in NASA has led to a revision of science textbooks to include everything we know about Pluto. This time, it is likely to regain planet status. Here's why. Our knowledge of Pluto doesn't end with the controversial IAU decision in 2006. In fact, it is the new and restored capabilities of the James Webb Telescope that have provided the pictorial evidence needed to strengthen our theoretical understanding of this putative planet. Although past observations classified which objects are considered planets and which are not, the IAU had little solid data on which to rely. The criteria used for this classification may have been questionable after the 2006 decision. 2 different scientific positions on the issue emerged. Some believed that the IAU was hasty in declaring Pluto a dwarf planet, while others quickly embraced the new non-planet status. Most space pioneers have remained undecided on this issue. However, thanks to the fascinating discoveries of the James Webb Telescope, the question of Pluto's status remains. The first sharp images of Pluto provided by NASA are rewriting our understanding of cosmic history. The first and primary human encounter with Pluto was conducted by the New Horizons mission, which has been ongoing for a considerable length of time. In July 2015, the mission achieved its goal by passing near Pluto and its many moons. This was the first time humans were able to get a close look at the space artifact and gather the most complete data set to date about its moons and surface. The New Horizons mission opened up exceptional opportunities for NASA in its exploration of the Kuiper Belt, a distant region of space. The fundamental success of the mission was the detailed study of Pluto, now considered a dwarf planet, and its largest satellite, Charon. It also managed to capture clear images of the 4 other satellites known as Nix, Hydra, Kerberos, and Styx. Over a period of 15 months, the mission gathered data, including the encounter with Pluto and Charon, amounting to 6.25 gigabytes. What does this data mean for NASA in relation to the dwarf planet? First, the findings were so remarkable that scientists had to develop new data models to better understand Pluto's surface and atmospheric conditions. It was found that the dwarf planet was undergoing significant changes in its surface and atmosphere. It was clear that Pluto was far from being a dormant body. It was evolving at a rate that surprised NASA and challenged what was previously believed about this putative planet. The New Horizons mission was historic, and its encounter with Pluto took place nearly quite a while back. Since then, the field of space exploration has seen dramatic improvements through technological advancements. With the addition of the James Webb Space Telescope, the possibilities are becoming endless. One might even say that we are getting increasingly close to a complete understanding of our solar system. However, there is an issue with missions like New Horizons and any decisions to explore planets farther from the Sun. The problem lies in the prioritization of resources, as investing millions to study a scientifically significant planet might raise questions about the existence of possible life elsewhere. Why head to the edges of the solar system? These are challenging questions to be sure. However, the New Horizons mission marked a turning point in the history of space exploration. Not only did it open new avenues for NASA to invest in the study of Pluto, but it also sparked our interest in further exploration beyond the known boundaries. In the case of Pluto, its study is key to building a broader scientific understanding of other small planets. Despite its location in a cold, dark region of the universe, the first images of its surface proved significant enough to reveal that Pluto is an active object in our solar system. As they say, a picture is worth 1,000 words, and these crystal-clear images from NASA provide us with valuable information. First, Pluto was found to have a heart. Most geological phenomena on this dwarf planet are driven from its core, scientifically known as Sputnik planum. Surprisingly, it turns out that Pluto literally wears its heart on its sleeve. A quick look at NASA's high-resolution images revealed that this heart is a white, cold, and nearly frozen left ventricle of Sputnik's heart. It resembles a vast nitrogen glacier spanning thousands of square kilometers. Another notable geographical feature of Pluto's surface is that the axis of its rotation has undergone significant reorientation, what scientists call a precession process. This was unknown to NASA before the mission. The dwarf planet's basin is in the opposite position than expected. This reorientation has important implications for understanding the dynamics and evolution of Pluto as a planet. In simple terms, the tidal interaction between the moon Charon and Pluto is being influenced by Sputnik planum, the heart of the dwarf planet. This effect has reoriented Pluto so that its basin is more closely aligned with a tidal axis, something that was not previously known. We have always known that this ancient planet is fascinating for obvious reasons. However, what was not known is that Pluto's icy surface also causes a tilt due to the imbalance in its mass. The core of the heart of the dwarf planet is a 4 kilometers thick layer of ice, which is very likely contributing to that titanic mass. When combined with tides, this process can cause the reorientation of the planet's rotational axis, seeking balance on its own orbit. However, the glacier alone is not sufficient to produce a steep reorientation angle or to cause significant shifts. As we mentioned earlier, technologically supported studies can alter our cosmic history, and this is just such a moment. Scientists have also discovered that Pluto is a world with an ocean of its own beneath its thick ice sheets and glacier-covered surface. Pluto's interior contains an extensive ocean that also influences the reorientation of its rotational axis. This discovery is phenomenal for multiple reasons, but most importantly because it completely changes our understanding of the planet. The highly probable presence of an ocean in Pluto's exterior means that we will have more information about its origin and how it formed. The discovery of an ocean beneath Pluto's icy surface has ignited new questions and possibilities in planetary science. It challenges our understanding of what constitutes a habitable environment beyond Earth, and prompts us to rethink the dynamics of celestial bodies in the far reaches of our solar system. This ocean, speculated to exist based on gravitational data and now strongly supported by the New Horizons mission's findings, represents a potential reservoir of liquid water beneath a frozen exterior. Understanding Pluto's geological processes is critical to comprehending its evolution over billions of years. The dwarf planet's surface features, including its distinctive heart-shaped region and the unexpected reorientation of its rotational axis, provide tantalizing clues. Sputnik planum, the heart's left ventricle, acts as a unique geologic feature. It is believed to be a massive basin that may have formed due to a subsurface ocean freezing and causing the surface to collapse, or perhaps due to an impact that exposed material, leaving a deep depression. The New Horizons spacecraft's encounter with Pluto in 2015 revealed a dynamic world far from the cold, inert body it was once thought to be. The mission captured detailed images of Pluto's varied terrain, including mountains made of water ice, vast plains of nitrogen ice, and regions with complex patterns resembling cellular networks. These features suggest active geological processes, potentially driven by internal heat sources or interactions between surface materials and Pluto's thin atmosphere. Pluto's atmosphere, although thin compared to Earth's, plays a crucial role in its surface dynamics. It consists primarily of nitrogen, with traces of methane and carbon monoxide. The atmosphere undergoes significant changes as Pluto's elliptical orbit takes it closer to and farther from the Sun, causing surface materials to freeze and sublimate in response to temperature variations. The New Horizons mission's discoveries extended beyond Pluto itself to its system of moons. Charon, Pluto's largest moon, displayed an unexpectedly diverse landscape, including a massive canyon deeper than the Grand Canyon and a dark region nicknamed Mordor for its distinctive coloration. Other moons, such as Hydra and Nix, exhibited irregular shapes and cratered surfaces, indicating a history of impacts and geological activity. NASA's study of Pluto and its moons exemplifies humanity's ongoing quest to explore and understand the vastness of our solar system. Each new discovery, from the existence of a subsurface ocean to the intricate surface features shaped by geological processes, adds a layer of complexity to our understanding of this distant world. As technology continues to advance, the potential for further exploration of Pluto and the Kuiper Belt beyond remains immense, promising to reveal more about the formation and evolution of our solar system's outer reaches. The reclassification of Pluto in 2006, which reduced its status from planet to dwarf planet, remains a topic of debate among scientists and space enthusiasts alike. However, the data gathered by New Horizons, coupled with insights from the James Webb Space Telescope, may prompt a reconsideration of this decision. Pluto's complex geology, active surface, and potential subsurface ocean suggest that it is more than just a simple object in the Kuiper Belt. These findings challenge our definitions of what constitutes a planet and encourage us to continue exploring the mysteries of our solar system. As we look to the future, the exploration of distant celestial bodies like Pluto offers a reminder of the boundless curiosity that drives scientific discovery. The knowledge gained from these missions not only enhances our understanding of the universe, but also inspires new generations to look up at the stars and wonder what lies beyond. Whether or not Pluto regains its status as a planet, its place in the history of space exploration is secure, and its mysteries continue to captivate those who seek to unravel the secrets of the cosmos.